This video demonstrates how vortex rings reflect under the free surface of water. Here is the aquarium setup. These are turbulent vortex rings being shot horizontally at about 1 meter per second. That was 3 quick shots in real time, and now we're seeing 3 shots in slow motion. What you see, however, is not the water rings themselves, but air bubbles trapped in the water rings. These bubbles are captured by the ring as it is formed by the ring gun. After the bubbles are captured, they are simply carried along with the ring. Here is a close-up of the ring gun in action. The rings are formed by pulses of compressed air, about 100 pounds per square inch. A diaphragm in the ring gun passes the impulse to the water. As the water exits the gun, the ring is formed just outside the opening. The bubbles in front of the gun are picked up in the process. These are shots of the process at varying rates of slow motion, 8 times, 16 times, and 32 times. Now to the reflection. First we shoot rings at a shallow angle to the surface. 3 quick shots in real time, and then 3 shots in slow motion. Notice the small wave on the surface. This disturbance in the surface seems disproportionately small considering the energy carried by the ring. What do you think? After watching the whole video, go back and review the real-time shots. Here is a slow motion close-up of the reflection from above the surface, and then a slow motion close-up of the reflection from below the surface. Now we are going to shoot rings at a much steeper angle. As before, 3 shots in real time and then 3 shots in slow motion. The surface wave is now much larger. The turbulence of the ring and the surface tension of the surface make the wave even more interesting. Still, it seems to me that this surface disturbance is small relative to the energy and momentum carried by the ring. Again, here are close-ups of the reflection from above and then from below the surface. One cannot help but be amazed at how such high-energy vortex rings so effortlessly reflect at the free surface. For each ring, however, there is a critical angle beyond which it will not reflect. Observe what happens when the angle is too steep